I'm going to talk today about science, ocean science and technology, and the idea of spatial data acquisition and its application. So I start with the position that the ocean is the most important thing everywhere. You guys that aren't studying the ocean aren't studying the most important thing. And that we really need new approaches to understanding something that's been a long-held mystery in the ecology of the globe. And we're approaching this today with a new approach that oceanography has never gone before, and that is the cable observations, the use of ROVs, AUVs, things like that. So we're advancing technology into the observations of the ocean. Most of the ocean is kind of boring and the seafloor, but there's amazing opportunities for discovery in methane gas evasions, different species, things that no one has ever seen or actually ever understood. Only 5% of the ocean has actually been visited. So we're doing that by starting a course program here at the UW for undergraduates in ocean science and technology, where we're building our own cabled observatory off our dock. We're building sensors and learning about power and data consumption for observation. We started this in the spring. We had our first class where students actually built some of their own sensors from scratch using microcontrolled processors, learning about data consumption, buoyancy, and all of those things. And it worked. For the most part, everything sort of maybe worked. One of the technologies that we drive our students towards is the way to make observations remotely. And in oceanography, instead of using light for observations, we use sound, so it's acoustics. And acoustics is a fundamental part of it. That's why we focus on the use of sonars. We teach a course here where we're teaching people to operate multi-beam sonar systems. And this is us in Lake Union over some of the sunken vessels that are out there. And we're using those to get students excited about surveying and the method of doing that. It's a very interesting science in that you're putting sound into the water column and you're measuring the time for distance calculation in the return based upon the angle off of the ship. So there's a lot of science behind and math behind doing it. As you improve your ability to put sound onto the ocean and measure it, you're able to record high-resolution bathymetry and structural geology of the seafloor. So this is just an example down around Tacoma of where we've done this. You see a lot of other interesting things on the seafloor. These are pipelines. That's actually a dead body up there. There's airplanes and sunken vessels and things like that. So you're never really quite sure what you'll see down there. One of the advances that's happening right now, it's about a 4-year-old technology, is to look at the backscatter in the water column. So not just looking at the sound returns from the floor, but from things in the water column. And these are methane gas evasions off the seafloor. So you can think of this as a slice through the water column as the ship progresses. You're being able to look at zooplankton, phytoplankton, sediment plumes, gas evasions, and things like this. So you're really beginning now to look at a three-dimensional mapping approach to the sea. These are gas fields, evasions off the floor. Because we're doing this with multi-beam, we're able to calculate the volume of the gas fields, the response to current and wave motion, and the height of these columns. So here you can see over 1,000-meter gas plume evading off the Washington coast is about 150 meter. I'm sorry, about 1,000 meter. Yeah, so this almost reached the surface. This technology then lets us look into the three-dimensional volume of the ocean and correlate it with species, and these are fish populations hovering around methane gas evasions off the Washington coast. This is also a technology to be able to take the water column backscatter data, so what's occurring off the floor, capture it through the software, and then add those off the floor returns to the on the floor returns to produce three-dimensional objects as a spatial data object in space. So this is typically represented by being able to map the mast or railings or things like that off a sunken vessel. But clearly it can also be used to put a three-dimensional object of gas fields into space. So in summary, oceans are important. There's a lot of really interesting things to see out there. We do this through remote observation spatially, and we're training students right now